Imagine a world where the most terrifying predator wasn't stalking the land, but lurking beneath the waves. A creature so massive, so powerful, that it made the great white shark look like a minnow in comparison. This was Otodus megalodon, the undisputed apex predator of Earth's oceans for over 20 million years. With teeth the size of your hand and a jaw powerful enough to crush a car, the megalodon was evolution's perfect killing machine. And then, rather suddenly in geological terms, it vanished. Today, we're diving deep into one of paleontology's most enduring mysteries: what caused the extinction of Earth's ultimate predator? The answers reveal not just the fate of a prehistoric shark, but profound lessons about survival, adaptation, and the precarious nature of dominance in our planet's ever-changing ecosystems. To understand the megalodon's disappearance, we first need to appreciate what made it so formidable. Growing up to 60 feet in length, roughly the size of a school bus, and weighing as much as 70 tons, the megalodon wasn't just big. It was perfectly designed for hunting. Its massive jaws could generate a bite force estimated at over 40,000 pounds per square inch, easily enough to crush the bones of the largest whales. For context, that's about 10 times stronger than a great white shark and more than 20 times stronger than a lion's bite. The megalodon's hunting strategy was brutal but effective. Unlike modern sharks that often take exploratory bites of their prey, the megalodon would target the fins and tails of large marine mammals, immobilizing them before delivering the killing blow. Fossil evidence shows bite marks on whale vertebrae that could only have been made by something of the megalodon's size and power. This wasn't just a predator, this was nature's perfect killing machine. So what could possibly bring down such a dominant species? For decades, scientists have debated this question, and several compelling theories have emerged. Let's examine each one to piece together the megalodon's final chapter. The first suspect in our investigation is climate change. Not the human-induced variety we're experiencing today, but a natural cooling of Earth's oceans that began around 3 million years ago. As the planet entered what geologists call the Pleistocene epoch, global temperatures dropped significantly, leading to the formation of ice caps and glaciers. This period, often referred to as the Ice Age, dramatically altered marine ecosystems worldwide. For the megalodon, this cooling was catastrophic. Evidence suggests that these massive sharks preferred warm, tropical waters. As ocean temperatures dropped, their habitat began to shrink. The cooling waters would have slowed their metabolism, making it harder for them to maintain the energy levels needed for hunting. Imagine trying to run a marathon while gradually being forced into hypothermia. That's essentially what happened to the megalodon on an evolutionary timescale. But climate change alone doesn't fully explain the megalodon's extinction. After all, many other marine species adapted to the cooling oceans. This brings us to our second suspect: competition from newly evolved predators, particularly the ancestor of today's great white shark. Around the same time the megalodon was struggling with changing ocean temperatures, a new player entered the game. Carcharodon carcharias, the great white shark, first appeared in the fossil record about 4 million years ago. Though significantly smaller than the megalodon, the great white had several advantages. It was more agile, could tolerate colder waters, and had evolved serrated teeth perfect for slicing through flesh rather than crushing bone. This created a competitive dynamic that put pressure on the megalodon, especially when it came to hunting smaller prey. While adult megalodons primarily hunted large whales, their juveniles would have targeted smaller marine mammals and fish, the same prey that great whites were efficiently hunting. Essentially, the megalodon's children were being outcompeted at the dinner table. Recent research has revealed something even more fascinating, and perhaps damning for the megalodon. DNA analysis suggests that great whites and their relatives may have actually preyed upon juvenile megalodons. Imagine being the ocean's top predator, only to have your young hunted by smaller competitors. This would have created a devastating population bottleneck, with fewer megalodons reaching reproductive age. The third factor in our extinction equation involves the megalodon's primary food source, whales. The fossil record shows that around 2 to 3 million years ago, there was a significant extinction event among small and medium-sized whale species. precisely the size range that would have been ideal prey for megalodons. At the same time, the surviving whale species were evolving to be faster swimmers and were beginning to migrate to colder polar waters where megalodons couldn't follow. This created a perfect storm for the megalodon. Their preferred prey was disappearing, and the remaining food sources were either becoming too fast to catch or were moving to waters too cold for the megalodon to hunt efficiently. It would be like a lion suddenly finding that all the zebras and gazelles had either gone extinct or learned to outrun them, a death sentence for a specialized predator. But there's another fascinating theory that's gained traction in recent years, and it involves looking to the stars. Some researchers have proposed that Earth was hit by a supernova event approximately 2.6 million years ago, right around the time the megalodon disappeared. When a star explodes in a supernova, it releases an enormous amount of radiation, including muons that can penetrate deep into the ocean. Evidence for this theory comes from an unusual spike in a rare iron isotope found in ancient seabed deposits dating to this period. If a nearby star did explode, the resulting radiation could have caused widespread mutations and cancer in marine life, with larger animals like the megalodon being particularly vulnerable due to their longer lifespans and the greater number of cells in their bodies. While this cosmic catastrophe theory is certainly dramatic, most paleontologists view it as a contributing factor rather than the primary cause of the megalodon's extinction. It's more likely that the supernova, if it occurred, delivered the final blow to a species already struggling with climate change, competition, and food scarcity. There's also a fifth factor that's often overlooked but might have been crucial: the megalodon's reproductive strategy. Modern large sharks, like the great white, have relatively low reproductive rates. They produce few offspring, which take years to reach maturity. The megalodon likely had a similar reproductive pattern, but even more extreme due to its massive size. Female megalodons probably gave birth to live young after a gestation period that could have lasted years. Their pups would have been born relatively large, perhaps 6 to 8 feet long, but would have required many years to reach reproductive age. This slow reproductive cycle would have made it extremely difficult for megalodon populations to recover from any significant decline. When we combine all these factors, a clearer picture of the megalodon's extinction emerges. It wasn't any single catastrophic event that doomed Earth's ultimate predator, but rather a perfect storm of environmental changes and biological pressures. The cooling oceans restricted their habitat and slowed their metabolism. Competition from more adaptable predators like the great white shark threatened their young and competed for food. Their primary prey was either going extinct or evolving to be faster and migrating to colder waters. Possible cosmic radiation from a supernova may have caused genetic damage, and their slow reproductive rate meant they couldn't adapt quickly enough to these mounting pressures. The megalodon's story offers a profound lesson about the nature of evolutionary success. For 20 million years, the megalodon was the perfect predator for its environment. Its massive size and power made it virtually unstoppable. But when that environment changed, the very specializations that had made it so successful became liabilities. The megalodon had evolved to be the ultimate predator in warm, stable oceans filled with large, slow-moving prey. When those conditions changed, it couldn't adapt quickly enough. In contrast, the great white shark, which we often think of as the ocean's perfect predator today, succeeded precisely because it was more adaptable. It could tolerate a wider range of temperatures, hunt a more diverse array of prey, and reproduce more efficiently. The great white wasn't necessarily better than the megalodon. It was simply better suited to survive in a changing world. This pattern of specialized apex predators being replaced by more adaptable competitors is a recurring theme in Earth's history. The same fate befell the dinosaurs, the saber-toothed cats, and countless other dominant species. It's a reminder that in evolution, adaptability often trumps raw power. The megalodon's extinction also highlights the fragility of marine ecosystems. Even the ocean's most formidable predator couldn't survive when its ecosystem was disrupted. This should give us pause as we consider the impact of modern climate change and overfishing on today's marine predators. The great white shark, the orca, and other apex predators play crucial roles in maintaining healthy oceans. If they were to disappear, the consequences would ripple throughout marine food webs. Perhaps the most intriguing aspect of the megalodon's story is what it reveals about extinction itself. The boundary between existence and extinction is often blurrier than we imagine. The megalodon didn't disappear overnight. Its population likely dwindled over thousands of years as conditions gradually became less favorable. There may have been small pockets of megalodons hanging on in isolated warm water refuges long after the main population had collapsed. This gradual decline raises a provocative question. Could the megalodon still exist in some remote corner of our oceans? Despite what sensationalist documentaries and novels might suggest, the answer is almost certainly no. Our oceans have been thoroughly explored, and a predator of the megalodon's size would require enormous amounts of food that would have to come from the same marine ecosystems we've studied extensively. The absence of any credible sightings, modern teeth, or other evidence makes it clear that the megalodon truly is extinct. However, the megalodon lives on in a different sense. Its evolutionary legacy continues in the form of the large predatory sharks that swim our oceans today. The great white, the mako, and other lamnid sharks carry forward adaptations that first evolved in the megalodon's ancestors. In this way, something of the megalodon still patrols our oceans, albeit in a smaller, more adaptable form. The megalodon's extinction also offers a sobering reminder of our own species' vulnerability. Humans have achieved dominance through our adaptability and technology, but we too depend on stable ecosystems and resources. As we alter Earth's climate and ecosystems at an unprecedented rate, we would do well to remember the megalodon, a species so powerful it seemed invincible until changing conditions proved otherwise. As we conclude our exploration of the megalodon's extinction, it's worth reflecting on what we've learned. The disappearance of Earth's ultimate predator wasn't due to any weakness or evolutionary failure. Rather, it was the result of extraordinary bad luck, a convergence of climate change, competition, prey depletion, and possibly cosmic radiation, all hitting a specialized predator with a slow reproductive rate. The megalodon's story is a reminder that in nature, there are no permanent victories. Even the most successful adaptations can become liabilities when conditions change. The true measure of evolutionary success isn't dominance at any single point in time, but the ability to adapt and persist through changing conditions. Today, as we face unprecedented environmental changes, the megalodon's extinction offers both a warning and a lesson. A warning that even the mightiest can fall when ecosystems change too rapidly, and a lesson that adaptability, not power, is the ultimate survival trait. Perhaps by understanding why Earth's ultimate predator vanished, we can gain insights that will help prevent today's magnificent ocean predators from sharing the same fate. The megalodon may be gone, but in studying its rise and fall, we gain a deeper appreciation for the complex and delicate balance that sustains life in our oceans, and the profound consequences when that balance is disrupted.